All right, so we're going to look at a few different word problems that we can use factoring to solve. One of the first types of problems we're going to see is a consecutive integer problem. Now, we know that we've done consecutive integer problems in the past, and that involves starting with an unknown integer called x or n, and then increasing from there. Now, if it's just consecutive integers, then the integers would be x, x plus 1, x plus 2, x plus 3, and so on. If we're doing consecutive odd integers or consecutive even integers, we go x, x plus 2, x plus 4, x plus 6, because to get to the next odd, you have to go up by 2, or to get to the next even, you go up by 2. So let's take a look at this problem here. We have to find two consecutive positive odd integers whose product is 35. So a little bit of information in here. First of all, two consecutive positive odd integers. Well, if they're odd integers, then my first one's going to be x, as it always is. To get to the next odd number, I have to go up by 2. So the next one's going to be x plus 2. All right. I don't seem to be able to make sure that they're positive or odd yet, or positive at least. I've made sure that if one's odd, the other one's odd. And I know their product is 35. So in order to make that happen, I have to remember that product means multiplication. So I'm going to show that x times x plus 2 equals 35. Now the goal here is to solve for x. In order to do this, what I'm going to actually have to do is distribute first, because I can only use the zero product property, and right now these things are multiplying to 35. So when I distribute the x's, x times x is x squared, x times 2 is 2x, and that equals 35. Now I want to subtract 35 from each side so that I can get my polynomial equal to 0. This will allow me to set up the zero product property. I have a regular trinomial here, x squared plus 2x minus 35, and I want to factor that. So I can actually use the little x puzzle. I need to figure out what two numbers multiply to negative 35 and add up to 2. And a little thought, I realize one's positive, one's negative, the bigger one's positive. It's going to be 7 and negative 5. Now, because this is a nice trinomial where the x squared has a coefficient of 1, I can jump right to the factored form, which is x plus 7, and multiply that by x minus 5. That would equal 0. If I wanted, I could multiply that back out to check my work, but it should bring me back to my original equation. And now I know I can use the zero product property, so I split this up into two different cases. First one, x plus 7 equals 0. Second one, x minus 5 equals 0. Now solving each of those gives me x equals negative 7 and x equals 5. So now I go back to my original problem to check which of these answers I want. Maybe both, maybe none, we'll see. I need my answers to be positive odd integers. Negative 7 is odd, but it's not even. I'm sorry, but it's not positive, it's negative. So I'm actually going to cancel out that answer and throw it away. The answer that I do want is x equals 5, because that is a positive odd integer. So now if I go back up to my original variables, my x would be 5, my x plus 2 therefore would be 7. And I'm pretty sure that I can check this now and find out that 5 and 7, they are consecutive positive odd integers, and they have a product of 35, 5 times 7. You may be able to figure out that the numbers were 5 and 7 right away. That's not the point. You've got to be able to do it using this factoring method. Just getting 5 and 7 won't get you close to full credit. You've got to use the factoring method to get there. All right, let's see another type of problem. And here's another type of word problem we could have, similar to the last one, but just a different type of number problem. We're told that 8 less than triple an integer's square is the same as double the integer. So we have to translate this into an algebraic expression in order to find the number that we're looking for. And so I guess we'll use x to represent the number, which is an integer. And we need 8 less than triple an integer's square. So triple the integer's square, that means I'm going to square it, and triple it means times 3. Now 8 less than that is minus 8. So 3x squared minus 8 is the same thing as saying 8 less than triple an integer's square. Now is the same as definitely means equals. Double the integer would be 2x. So there we have our equation set up, and now we just have to find the number by solving for x. Once again, I have to get one side to equal 0, so I'm going to subtract 2x from each side. 3x squared minus 2x minus 8 equals 0. And I want to factor this. Now I have to use this special x puzzle because my lead coefficient is x squared. So I'm going to do 3 times negative 8, which brings me to negative 24. And put that in the x puzzle over negative 2. And what two numbers multiply to negative 24, add up to negative 2? That's going to be negative 6 and positive 4. So remember that when I'm doing this, I have to rewrite it, replace my negative 2x using the 4 and the negative 6. So I'm going to have 3x squared plus 4x minus 6x minus 8 equals 0. 4x minus 6x is the same thing as negative 2x, but now I try to group. So I've got these groupings here, and I look at 3x squared plus 4x. The 3 and the 4 don't have a greatest common factor greater than 1, so I'm only going to take out the x, which would leave behind 3x plus 4. And I want to get 3x plus 4 for the next one. They actually, the negative 6x and negative 8 both have a 2, and I can both take a negative out of both as well, because that will leave me with the 3x plus 4 that I want in parentheses. Now remember that to finish up that factoring, the 3x plus 4 goes in its own set of parentheses, and the x minus 2 goes in the other set of parentheses. Now I can use the zero product property, so I split them up into two different equations. 3x plus 4 equals 0, and x minus 2 equals 0. If you solve each of these, you get x equals negative 4/3, or x equals 2. Now, since we're told that my original number is an integer, that means it's not a fraction or a decimal, so I actually have to throw out this answer. Nothing wrong with the way I solved it, but it's just incorrect. And the result that I get is x equals 2. That's going to be my final answer. If I want to do a little bit of a check, I would just think about plugging it back into my original. And that would be 3 times 2 squared minus 8 should equal 2 times 2. So I've got the integers square first. That's 2 squared is 4. Then I'll have to triple it. That makes it 12. And 12 minus 8 is 4. That's 8 less than 12 would be 4. And double the 2. 2 times 2 is also 4. So my check works. And that's all there is to it. Hope this is clear. All right, so now let's take a look at a geometry problem. These are pretty common here. We're going to start off with a square field that has 5 meters added to its length and 2 meters added to its width. The field then has an area of 130 square meters. Find the length of a side of the original field. Definitely for a problem like this, I'm going to need a diagram. So I'm going to start with my square field. All right, so there you can see the square. I have no idea what the original side lengths are, but they're all the same. They're all x meters. So now what I'm going to do is I'm going to add 2 meters to its width, 5 meters to its length. Doesn't matter which one I treat as its length and width, as long as I make it a rectangle, it's ultimately what it's going to be. So let me add in those distances. All right, so you can see that what I've done here is I have added 5 meters to the vertical dimension, which is going to be its length, and then 2 meters to its width horizontally. Now the field has an area of 130 square meters. Well, I have to know what the area is, and area comes from the formula length times width for a rectangle, excuse me. And so I need to know the total length and total width of this rectangle. Well, since I have x meters here and 2 meters have been added on, then I actually know what the entire width is. It's going to be the same at the top and the bottom. It's going to be x plus 2 meters. And then I can do the same type of thing for the length. I have x meters here, another 5 meters here, so the entire length is going to be x plus 5 meters. And so now that I know my width and my length, x plus 2 and x plus 5, I can plug into my formula. Now I know the area is 130 square meters, and the length is x plus 5, and the width is x plus 2. So just like before, I'm going to need to simplify this by multiplying and then move some things around. So I'm going to do x times x gives me x squared. X times 2 is plus 2x. 5 times x is plus 5x. And finally, 5 times 2 is plus 10. And bring down my 130. And I have to get a zero product property, so I'm going to move 130 to the other side. I'll keep my x squared. I'll combine those two like terms to get plus 7x. And 10 minus 130 is negative 120. So now what I need to do is I need to figure out how this factors. So that's using an x puzzle. I just have a lead coefficient of 1. It's 1x squared, so I can just do negative 120 up top, 7 on the bottom, and I'm looking for the two numbers that are going to multiply to negative 120 and add up to 7. And those end up being 8 and 15. I just need to make the 8 negative. So that means I can factor this to be x minus 8 times x plus 15. And that's going to give me two different equations when I split these up using the zero product property. X minus 8 equals 0. X plus 15 equals 0. That's a 0 there. Let me see if I can fix that up. There we go. That's a little bit better. And so my two solutions are x equals 8, x equals negative 15. Now because x is a dimension of my, my field, I know that it can't be a negative value. That doesn't make any sense. So x equals 8 is going to be the solution that I want. And if I go back in to my problem, I can really just check that. And I see that that's 8 meters on each side, which actually would make the entire width be 10 meters because I'm adding 2 to that, 10 meters there. And the entire length would be 13 meters. And I can see pretty clearly that that would have an area of 130 square meters. 10 times 13 is 130. And so there you go. That's using factoring to solve a geometry word problem.